There's a perfect storm headed straight for us. A storm centered on health and disease in America. It's fueled by three converging trends: the increasingly poor health of most Americans, the rapidly aging population, and the unrelenting growth of healthcare costs. Being obese is defined as having a body mass index of 30 or more based on height and weight, as shown by the table. In the late 1970s, around 15% of American adults were obese. In the ensuing 25 years, that percentage doubled. Add in the people who are overweight without quite being obese, and in today's America, only 1 out of 3 adults maintains a healthy weight. Likewise, diabetes has been skyrocketing. One of the most troubling statistics is that diabetes among Americans in their 30s increased 70%, almost twofold, in less than 10 years, from 1990 to 1998. Both obesity and diabetes act as signal problems, opening the door to many other diseases and ailments, including certain types of cancer, heart disease, arthritis, and blindness, among others. Based on the dramatic rise in obesity alone, researchers recently wrote in the New England Journal of Medicine, "The steady rise in life expectancy observed in the modern era may soon come to an end, and the youth of today may, on average, live less healthy and possibly even shorter lives than their parents." In 1900, the percentage of the population aged 65 and older was a scant 4%. In 1950, that figure grew to 8%. By 2000, 12.4% of us were 65 years of age or older, and by 2030, it is projected that 20%, or 1 out of 5 U.S. individuals, will be at least 65 years old. This has enormous financial implications because older citizens consume more health care. In 2000, people aged 65 and older were only 12.4% of the population, but they accounted for over 36% of personal health care expenditures. This is compounded by the simultaneously shrinking proportion of adult workers. In 1960, adult workers in our economy aged 20 to 64 outnumbered the elderly by a ratio of 5.7 to 1. In 2030, that ratio will shrink to 2.7 workers for every elderly person. Almost 1 out of every $6 spent in this country goes towards health care, a figure that has risen dramatically in recent decades. In the past 40 years, healthcare costs as a percentage of our gross domestic product have increased 300%. The United States spends far more per capita on healthcare than any other country in the world, and the costs continue to outpace inflation. These exploding healthcare expenses have come to plague all sectors of our society, including small business, big business, local, state, and federal governments. The functionality of the country's automakers, airlines, supermarkets, and education systems is being increasingly hampered with each passing year. It's a perfect storm. A storm on the immediate horizon that will come to be one of the defining issues of the next 50 years. How will we face the challenge? What information do we have, and what information do we still need? What is the solution? This is my dad, Dr. T. Colin Campbell, the Jacob Gould Sherman Professor Emeritus of Nutritional Biochemistry at Cornell University. As author of over 350 scientific papers, my father has had a long and distinguished scientific career. With his students and colleagues, he spent the better part of 3 decades investigating biochemical details of nutrition and cancer, while simultaneously conducting human studies in the Philippines, China, and the United States. My father also has extensive policy experience, having served on several expert panels for the National Academy of Sciences and having participated in many other national and international deliberations. And he jogs year-round. And this is me in the late 1970s. My name is Thomas Campbell, and I am the youngest of 5 children born to Karen and Colin Campbell. I grew up largely oblivious to my dad's research, going off to school and majoring in theater arts at Cornell. I graduated in 1999, and a couple years later, while pursuing professional acting in Chicago, my parents offered me the chance of a lifetime. Move back to Ithaca, New York, and help my father write what was to be his magnum opus, a book for the public that would summarize the most important findings and lessons of his long career. Not being able to pass up such a special opportunity, I squeezed my meager possessions into my small car and I headed home. Our task was daunting: write a book that was true to the scientific literature and comprehensible to a layperson while being an engaging and interesting read. In this process, my father and I confronted many of the challenges posed by the increasingly poor health of the American population and the widespread confusion about food and health. We distilled hundreds of research articles into precious few pages and battled over whether we should embrace scientific thoroughness or readability for the layperson. Through it all, my dad and I kept coming back to one theme. If nutrition were properly understood and utilized, many of the healthcare problems we currently face as individuals and as a society might be alleviated, even eliminated. I learned that eating the right food is crucial to avoiding and even reversing many chronic diseases and conditions. A healthy diet and lifestyle can vastly improve the enjoyment and lessen the healthcare expense of our later years. And if healthy food and exercise were more widely embraced, we'd lower our society's reliance on the ultra-expensive drugs and procedures that drive our healthcare costs up. Of course, I also got to know my mother and father better and got a chance to see in depth the experiences my father had over his long career. Born in 1934 during the peak of the Great Depression, Thomas Colin Campbell did not have what you would call a leisurely childhood. He was raised on a moderately sized dairy farm in Northern Virginia as the oldest of 4 children.
Of course, I milked cows. We had a dairy most of the time I was growing up, and I actually first started milking a bit when I was as young as 5 years of age and continued off and on over the years until I went to graduate school. And as farms were those days, we had our own pigs and chickens and animals, of course, of different kinds, and we got our own eggs and meat and milk. I walked the fields, fished in the stream that was in our meadow where the cows were for the most part. I also was a trapper and a hunter as I got older. But actually, my father was an immigrant. He was a hard worker. We all had to work hard.
He first truly left the farm as a young man when he enrolled at Penn State, where he majored in pre-veterinary medicine.
Yeah, college life for me was really kind of a new experience. Basically walking sidewalks instead of fields. As a matter of fact, I remember when I went off to Penn State and had all those sidewalks to walk between classes, I preferred walking on the grass. That was more to my liking. I actually, for an undergraduate degree at Penn State, I did pre-veterinary medicine. The reason for that being the fact that, like all the other freshmen, I was tested too for what I probably would be most suitable for a career. And I got high marks in 2 areas. One was not surprising, that was farming. And the other was medicine, which was somewhat surprising. Sounded interesting, and so I combined the two. I didn't particularly want to be on call 24 hours a day to be a doctor. So I started to, I decided to do pre-veterinary medicine.
After 3 years of undergrad, he moved on to veterinary school in Georgia. It was here where he got his first call to nutrition.
At the University of Georgia Veterinary School, I would think I was in about the 4th class that had been held at that university, in that veterinary school, and it was a nice year, it was a good year, I enjoyed it. But then toward the end of the year, I got a telegram from a rather famous professor at Cornell University by the name of Clive McKay. I didn't know who Professor McKay was, but he sent a telegram offering me a scholarship to come to work at Cornell and to work on a graduate degree. And my first reaction to it was, wow, they want to pay me to go to school instead of my father paying them, or I, for myself, paying them. In any case, I got excited about it. I left veterinary school after 1 year and then went on to Cornell. My dissertation essentially was concerned with trying to figure out how to grow cows more efficiently so we could eat more of them, drink more of their milk.
It was during this graduate experience that Colin formed his earliest opinions of what good nutrition was.
My graduate research program was essentially focused on protein. And actually, I mean, we knew it at the time and for many years thereafter, and everyone else agreed that if there was the most important nutrient, it really was protein. And I didn't really question that. And of course, trying to figure out how to grow cows and sheep more efficiently so we could eat more of them was an issue of producing more animal protein. And of course, that whole idea actually fit in with my own life and my own belief system. And at home, for example, we had meals that always had meat, always had milk.
After receiving his PhD in animal nutrition with minors in biochemistry and microbiology, the newly doctored Dr. Campbell took a job at a small Virginia company near his hometown. It was at this first job that he met and fell in love with a girl 7 years younger, Karen Lee Margaret Crone.
I never took my eye off of her, quite frankly, after I got there. And finally, I got around to asking her out for a date and decided that one of the best things we could do was to go skiing. I had skied some when I was in graduate school in upstate New York, and I thought that would be a nice thing to do. And so, but the only problem was it was in the Washington area, and that area doesn't get that much snow, but there was a ski place west of there, a couple of hours west of there, and I thought, well, we need some snow, and I was going to pick her up on this Saturday morning, and finally, that Friday night, sure enough, it snowed about 4 inches or so. I went in to pick her up the next morning, and she had left a note saying that she didn't want to go because it was snowing. And I thought, well, that's a heck of a thing. But anyhow, I persisted and asked her out again, and finally took her to dinner at a fancy French restaurant in Washington, D.C. And almost 44 years later, as I sit here telling you this story, I did in fact find the love of my life, which I knew was the case when I first met her.
After their marriage, they moved to Boston, where Colin took a postdoctoral research position at the Massachusetts Institute of Technology. His work at MIT was to isolate an unknown chemical in chicken feed responsible for thousands of mysterious chicken deaths.
Yes, I worked for a total of about 2.5 years at MIT isolating that unknown chemical. It turned out actually to be very, very toxic. In fact, I learned toward the end of my work that perhaps this was the most toxic thing ever before discovered. In any case, I then went on to Virginia Tech, and I was at Virginia Tech moving on to other projects when I got a call one day to come back to Washington to testify about my work at MIT. And I then learned that the material that I was working on actually was a toxic contaminant of the spray that there was used in Vietnam to defoliate the forest, a spray called Agent Orange, and they gave a name to the toxic material called dioxin. So the stuff that I was working on earlier on was in fact dioxin. And then by that time, though, I had moved on to some other work, as I said, especially work that started in the Philippines.
Dr. Campbell left MIT to become a professor at Virginia Tech, where he began his nutrition research career in earnest. As the campus coordinator for a large malnutrition project in the Philippines, Colin was putting the lessons of his earlier education to good use. The project's purpose was to alleviate malnutrition in the poorest areas of the Philippines by creating and maintaining mothercraft centers. These centers largely functioned to empower mothers to better feed their children. One of the main strategies to improve the nutritional status of these kids was to feed them more protein.
Poverty in a country like the Philippines is really quite serious, as it is in most third world countries. And of course, along with poverty comes a lot of malnourished children. And malnutrition in children is basically related to one of two things, at least it was in those days. Either it's related to a lack of calories, in which case it's called marasmus, or it's related to a lack of protein, in which case it's called kwashiorkor. And of course, the lack of protein was of interest to us. Indeed, in many of the third world countries, many people believed in the nutrition community that it was a lack of protein that was chiefly responsible for some of the diseases that occurred, especially high quality protein. And by high quality protein, we really meant protein from animal-based foods. So that actually just fit in very well with my own training, my own background, to be involved in the Philippine project in order to arrange for greater consumption of high quality protein.
About 82% of all liver cancer cases in the world occur in developing countries. Because the disease is more common in poorer areas, it was often assumed in the 1970s that the disease was exacerbated by low animal protein consumption. However, as Dr. Campbell got into the Philippines project, he came to find something quite unsettling. Within the Philippines population, liver cancer, which is normally a disease that older people get, was being diagnosed in children as young as 4 years old. Furthermore, the children who were most likely to get the cancer were from the best-fed, wealthiest families. In other words, they were the kids consuming the most protein in general, and certainly the most high-quality animal protein. At this time, a research paper was published in the journal Archives in Pathology. It reported on an experimental animal study done in India investigating the role of aflatoxin and protein on liver cancer development. Researchers exposed a group of rats to an initial dose of aflatoxin, a carcinogen known to initiate liver cancer. Then, the rats were divided into two groups and fed two different levels of protein. Either 5% of total calories came from protein, or 20% of total calories came from protein. Amazingly, every single rat fed a low-protein diet avoided liver cancer, and every single rat on the high-protein diet got liver cancer or its precursor lesions.
The experimental animal research done in India was shocking, surprising to say the least. One of my senior colleagues, in fact, when I told him what in fact had been observed, that namely animals giving higher protein diets got more liver cancer, he basically offered the idea that surely they must have gotten the animal numbers mixed up. He couldn't really believe that. In any event, it was consistent. Those results were consistent with what I thought I saw in the children. And so we started then a project, an experimental research project that was to last for many, many years to confirm what the Indians had observed, what I thought in fact was real, and experiments to determine, really how it worked. I love being in the lab, especially with students. It's really a great learning experience. And at that time, little did I know that what we were starting was to lead to 27 years of consecutive studies that was funded for the most part by the National Institutes of Health.
Cancer proceeds in three basic stages: initiation, promotion, and progression. Cancer initiation occurs when a carcinogen, or a cancer-causing chemical, enters a cell, undergoes a chain of reactions, and ultimately produces a carcinogen byproduct that binds to the DNA, creating what are called DNA adducts. The cell then divides before the damaged DNA is repaired, creating cancerous daughter cells. Promotion is the much longer stage when these initial cancerous cells grow and replicate to form a detectable tumor. And progression is when the cancer wanders from its initial site in the body and does its ultimate damage. To investigate how nutrition affects the cancer process, Dr. Campbell and his colleagues and students started at the first stage, initiation. The researchers wanted to know how varying amounts of protein intake would affect the process by which aflatoxin, a potent chemical carcinogen for rats, initiated liver cancer.
Our research program really had two objectives when we started out. First, I really wanted to know whether or not we could confirm what the Indian workers had done, namely that higher intakes of protein actually increased cancer risk. And the second objective was to see how it might work. In science, we'd like to learn how it works. If we do, then we have more confidence in fact what we observe. We did many, many experiments and initially started out by studying the first stages of cancer called initiation. And what we really found was really quite amazing. It seemed like every time we looked for an explanation, biochemically speaking, of how it works, we found something.
The laboratory results indicated that feeding rats a low-protein diet can inhibit the first stage of cancer in many ways, including a smaller amount of carcinogen enters the cell, the complex enzyme system that ultimately produces the dangerous carcinogen byproducts is less active. Less toxic carcinogen byproduct binds to the DNA of the cell, and fewer cancerous cells ultimately are produced.
Finding so many different ways in which protein worked, in a sense, was quite frustrating, but on the other hand, it was very interesting. I mean, researchers tend to assume that fairly simple explanations like protein, for example, would act just in one way, and as long as we could find that, we'd have the answer. Instead, what we really found was that this protein effect on producing cancer was acting in so many different ways or different mechanisms.
Through several years of research, it was becoming very clear. A low-protein diet inhibits the initiation of liver cancer induced by aflatoxin in rats. But what about the second stage of cancer, promotion? Promotion occurs over a much longer period of time and may be the stage that is most strongly influenced by the environment, including nutrition. Initiation, on the other hand, occurs very quickly and likely is something that happens in all of our bodies throughout the course of everyday life. For example, while sitting at your breakfast table, you may be exposed to something, perhaps a chemical in the air or some form of solar radiation, that may initiate a cancerous cell in your body over the course of minutes, even seconds. But once you have such a cell, and it is likely that most of us do, the growth and reproduction of this cancer takes far longer, years, even decades, in the course of the human lifespan. And it is during these years and decades that our food choices have their most prominent effect. The cancer growth and reproduction period ultimately determines whether we ever get diagnosed with cancer.
We were excited to be working on the promotion stage because we thought it really offered the most promise. Specifically, we had evidence from some other studies that promotion was a reversible process.
Colin's group found that high-protein diets accelerate the formation of precancerous clusters called foci. Foci form after cancer initiation during the very early stages of tumor formation. They are strongly predictive of cancer growth and development. The level of protein needed to accelerate foci formation was the level above and beyond the protein required for routine function. The requirement for the rat was about 10% protein, and feeding protein above this level resulted in increased foci formation. Incidentally, the recommended human requirement is about the same level, 10%, and most Americans routinely consume much more than their requirement, going up to about 18 to 20%. Researchers even found that cancer promotion can be stopped or even reversed by a low-protein diet. This graph summarizes the results from a 12-week trial of alternating high and low protein diets. Cancer grows when the 20% high protein diet was fed for the first 3 weeks, but then is repressed by a 5% low protein diet fed over the second 3-week term. If the rat then gets a high protein diet again, the cancer growth quickly accelerates. But a second low protein diet again turns the cancer growth off. In essence, these findings show that liver cancer in rats can actually be turned on and turned off simply by varying the level of protein intake within a range that humans routinely consume.
The ultimate study involved our looking at the effect of protein over the lifetime of the animal and the formation of tumors during that 2-year period, instead of looking at the early foci formation. The findings were really remarkable. The high protein diets basically increased tumor formation dramatically. The lower protein diets did not, in fact, allow tumors to form. And in addition, we also saw something else that we had seen with the earlier studies, namely, when we could actually stop tumor formation simply by feeding the lower protein diets, even after the tumors are already present. This study was quite robust, it was strong, and essentially, in our minds, it really confirmed in spades what the early Indian researchers had first observed.
The protein the researchers were using to manipulate cancer promotion was casein, which makes up about 87% of cow's milk protein. Amazingly, when Colin and his students fed the rats high 20% protein diets composed of wheat or soy protein, the cancer did not grow.
These findings were really quite shocking, at least for me. I being from the farm and believing in milk being one of the most valuable of foods, and especially believing that milk protein was the source of the best kind of nutrition, it really made it very disturbing and provocative. And of course the implications that this research had for possibly other animal proteins too. It was essentially almost the opposite of everything I had learned and I had assumed about cow's milk and protein. But this research was reviewed by my colleagues. It was funded by the National Institutes of Health prior to getting reviewed by my peers. It was published in the very best journals. But still so, I was really interested in a larger context here. We had to be cautious. This was certainly not proof of casein causing cancer in humans. But nonetheless, it was intriguing. And of course, we had done the research in a rather expansive way, and so it was convincing as far as this particular model was concerned. But I was interested in going beyond this idea of just working with one nutrient and what effect is so often assumed. I was much more interested in putting this in a context of, let's say, a large variety of nutrients and other sort of food constituents in the form of food. And of course, that whole idea of maybe animal protein being a problem, possibly for cancer, maybe other diseases too, and not just one nutrient, but of course everything working together. It was a perfect lead-in to the opportunity that we then had in China that led eventually to the China study.
In 1982, Dr. Campbell had recently finished his role as a co-author of the National Academy of Sciences Expert Panel Report on Diet and Cancer, and he was presented with a once-in-a-lifetime opportunity to initiate a human study in China that could take all of his previous findings to the next level. This study, now known as the China Project, was, in a sense, a follow-up project to one of the largest biomedical surveys ever done. A survey cataloging mortality rates for the whole of China's population in the 1970s.
In the early 1980s, I had the good fortune of having a senior scientist from China by the name of Dr. Chen Zhishi visit my laboratory. He was, I believe, the first senior scientist from China to visit the United States. And Dr. Chen was an exceptionally competent and personally likable individual. We got on well, and we were sitting one day when just talking about our research, when we heard from one of my students that the Nova TV program the night before had shown this rather remarkable finding in China, showing that the Chinese government had just released an atlas of cancer distribution around the country, and in fact was showing that cancer was very common in some places and not in others. And as Dr. Chen and I talked, it turned out Dr. Chen knew who was the senior person in that group who did that remarkable nationwide study, Dr. Li Yao. And so as we talked on, we obviously started thinking about, wasn't there some way we could do a study in China to find out why it was that cancer was so common in some counties, for example, and not in others? And my interest, of course, was to follow up on a couple of ideas. One was to look at the causation of cancer comprehensively from a dietary and lifestyle perspective, first. And secondly, also, of course, had an interest in the extent to which our findings on animal protein, casein in this case, might bear some relationship to this.
And so began the Cornell-Oxford China project on diet, lifestyle, and mortality in the People's Republic of China. Assembling a team of international experts, Colin and his colleagues surveyed people from 65 rural counties. Health workers, in a standardized way, took blood samples, urine samples, food samples. They distributed and collected food and lifestyle questionnaires, and they actually went into homes to measure people's food intake over a 3-day period. In all, there were 6,500 adults that were surveyed, and researchers measured the astounding sum of 367 variables, including factors related to dietary intake, blood and urine biomarkers, disease rates, and other geographical and environmental factors. These characteristics and others made the China project unique, comprehensive, and high quality.
The China project was unusually unique compared to other human studies that had been done up to that time. Most of the other studies involved people consuming diets very rich in animal-based foods, very high in fat, very low in fiber, for example. In China, we had a population that was consuming a diet mostly made up of plant-based foods, very low intakes of animal-based foods. It was unique in the sense that it had a broad range of disease outcomes, a very wide range of disease outcomes, and a variety of different kinds of diseases. And furthermore, it was a very stable population. That is to say, people tended to live, at least in rural China where we did this study, tended to live in the same places all their lives, and they consumed locally produced food, and more or less the same kind of food year in and year out. That kind of property or characteristic is very, very useful in terms of doing experiments like this. The China project was unusually comprehensive. We had a rather large number of different survey sites. We had multiple different causes that we examined, different kinds of dietary and lifestyle factors, and many different kinds of disease rates to consider. We actually collected blood samples, urine samples, food samples, did questionnaires, and essentially we asked them everything we could in the time that was available. We also measured many different things, including many different kinds of nutrient characteristics and viral characteristics and toxic chemical characteristics, hormonal characteristics, and we ended up at the end of the study, after cleaning up the data, having 367 items of information, or variables, if you will. This was really ideal in the sense of considering the relationship between diet and lifestyle disease in terms of the multiple different kinds of factors that can play a role in causing these diseases. We believe, and many of our colleagues agreed, that the China project was really of unusual quality for a study like this. In considerable measure, this was due to our collaboration with Sir Richard Peto, one of the principal investigators of the project from the University of Oxford, as well as, of course, the inclusion of Dr. Chen in managing the operation in China. Richard Pito and his colleague Julian Borum actually helped us to design this study in a way in which we could check on the reliability of the data, which was important because the samples that we collected had to be analyzed, of course, and they were analyzed for the most part, in a sense, blinded to which county was which. And ultimately, we involved some 24 different laboratories from around the world to measure this information. We had really good disease rate data. The disease rate data actually were for individuals between the ages of 35 to 64 years of age, in whom these diseases are forming and for whom the disease rate measurements are probably most reliable. We also measured some variables like nutritional characteristics and biochemical clinical measurements. We measured some of these things in multiple different ways. I mean, for example, we measured iron status in 6 different ways. We measured blood cholesterol using 3 different kinds of methodologies. We measured the mycotoxin aflatoxin in 3 different ways. At the end of the study, we added up and we estimated that we involved some 800 person years worth of professional labor, many of whom, of course, were in China. There were a total of about 24 different provincial health teams that were involved in this project, as well, of course, as the 24 laboratories who did many of the analyses.
Because of these exceptional characteristics, the New York Times described the China project as the Grand Prix of epidemiology. The goal of this meticulous design was to learn something new about the relationships between diet and disease, and after the years of work and analysis, this goal was met.
The principal finding from this study, based on measuring the consumption of various and sundry kinds of nutrients as well as other factors, was that the consumption of even relatively small amounts of animal food were associated with the onset of Western kinds of diseases. Small intakes of animal food, for example, could begin to increase blood cholesterol, just as one example, which in turn then tended to relate to emergence of Western diseases like heart disease and the various cancers.
The data on blood cholesterol support the conclusion that increasing animal food intake may be unhealthy. Blood cholesterol was higher in populations that consumed more animal-based foods. There was a positive association. As the intake of several plant-based foods and nutrients increased, however, cholesterol levels were lower. The reason this appears to be important is that blood cholesterol levels, in turn, were associated with the illnesses more common to Western countries. In rural China, there were 2 groups of diseases that clustered together: diseases of affluence and diseases of poverty. Chronic conditions such as cancer and diabetes are more common in affluent countries. Illnesses such as tuberculosis, pneumonia, and parasitic disease are more common in financially strapped countries where malnutrition is prevalent and poor sanitary conditions encourage the spread of viruses.
The fact that there were 2 groups of disease, in a sense, these clusters of disease, geographically, also biochemically speaking, suggested that they would have, each group would have some common causes. Diseases of affluence, for example, Western diseases, were, in a sense, could be characterized as diseases of nutritional extravagance.
One of the great strengths of the China project was that it provided an unusually comprehensive network of data regarding various diet, lifestyle, and disease factors. The investigation of breast cancer illustrates this point. Breast cancer mortality in rural China was correlated with higher intake of dietary fat, which in turn is representative of animal food intake. But the investigation didn't stop there. Based on the work of other researchers, there are several known risk factors for breast cancer: early age of menarche, late menopause, high blood levels of estrogen and other female hormones, and high blood cholesterol. In rural China, higher dietary fat intake, along with several other indicators of animal food intake, was correlated with high blood cholesterol. Both of these factors, fat intake and blood cholesterol, were linked to higher blood hormone levels. Higher hormone levels were also linked to higher intakes of animal protein, meat, and milk. These higher hormone levels were, in turn, correlated with more breast cancer and an earlier age at menarche. The blood hormone levels of the rural Chinese women were about 1/2 of the blood hormone levels of British women. In addition, Chinese women experience fewer reproductive years because they have a later age of menarche and an earlier age at menopause on average. Taking into account both of these facts, Chinese women experience only 35 to 40% of the lifetime estrogen exposure of Western women. In turn, the Chinese women only had about 1/5 of the rate of breast cancer mortality. Enlarging this network of information, the prevalence of cancer in families in rural China also was linked to animal protein intake and all 6 biomarkers measured that were indicative of animal protein intake. In this example, the China Project offers an entire network of information, not just the single association between 2 variables so commonly seen in many other studies. This network supports the hypothesis that certain risk factors are especially important for breast cancer, and that nutrition seems to play a role in controlling these risk factors. Furthermore, these associations suggest possible benefits of consuming plant-based foods as opposed to animal-based foods. Many other cause and effect associations were examined and published, as shown by this list. By the time all of this analysis was complete, Dr. Campbell believed that the China Project, within the context of other research, offered support for this hypothesis. The closer we get to a diet comprised of whole plant-based foods, the better will be our health.
The results that we were getting in the China study were really quite remarkable and, quite frankly, surprising, because here was a society already consuming a diet almost entirely comprised of plant-based foods and very little animal-based foods. And so what, in effect, we were really seeing was that as soon as small amounts of animal-based foods began to appear in certain diets in China, that's when Western diseases began to appear.
Given these provocative findings, the China Project has not gone without criticism. Central to one of the more common arguments against the China Project is an idea called the ecologic fallacy. The ecologic fallacy points out that when comparing 2 single variables, a population-based observational study, such as the China Project, cannot prove anything about cause and effect relationships. Essentially, this argument states that correlations do not prove causation. For example, although telephone poles are more common in countries where there is more heart disease, and thus these 2 variables are positively correlated, this does not prove that telephone poles cause heart disease.
That criticism is true, it really is, but this was not the purpose of the China study. It was not designed to do that. What we were looking for in the China study was to look for broad-based relationships, and then exploring these relationships in some detail, looking at networks of effects involving multiple different factors and multiple different diseases.
A second common criticism is that findings drawn from a Chinese population have limited significance for a Western population. This is said to be true because our 2 populations are different in terms of genetics and various lifestyle factors.
First off, we have multiple studies showing that when populations move from one country like China to another country like the United States, they take on the disease risk of the country to which they move. In other words, they're responding in the same way that we would. Secondly, the Chinese and other societies like that respond just like we do, even though their diets may be somewhat different. They respond in the same way that we do, in multiple different ways. For example, as cholesterol levels go up, admittedly at the very low levels in China, they go up, and as they go up in response to the consumption of small amounts of animal-based food. And also as they go up, that's when heart disease begins to appear. And that's when various cancers also begin to increase. That kind of association, those associations are essentially the same as they also appear with Western population at much higher levels of disease. So I have no doubt about the relevance of the data from China compared to the United States.
And lastly, detractors sometimes look through the China Project monograph, which is a widely available book containing all of the data, and find a correlation between two variables that does not, on the surface, seem to support the idea that plant foods are healthier. Holding up these one or two exceptions, they say that the interpretation of the study as a whole may be flawed.
In the China Project, we had an exceedingly large number of associations between possible causes and possible effects. And about 8,000 of these associations between potential causes and potential effects were statistically significant. Now, it turns out that the vast majority of these statistically significant associations supported the hypothesis that the closer we get to a plant-based diet, the healthier we're going to be. Specifically, if we have 10, for example, statistically significant associations, it's my judgment that about 9 of the 10 would support the hypothesis. The one that didn't in this example can easily be explained away because it usually represented a very narrow range of exposure for the thing that was being measured, or it represented an inaccurate measurement. To give an example of the problem with measurement, heart disease hardly exists in China. It's almost non-existent in many areas of China before the age of 64. When heart disease doesn't exist as an effect, obviously in a situation like that, if you're going to correlate something with heart disease, it's going to be meaningless. There are, of course, some criticisms coming from people who don't seem to understand statistics very well, who want to take the occasional exception to this general collection of associations, to take the exceptions and and criticize the study just with these occasional exceptions. I have to say it's an extremely superficial criticism, and usually represented by people who really don't understand what we did and don't understand the basis for the statistical analysis.
When the China study findings were first published, I remember I was still in high school. At that point, my family slowly started to cut back on meat consumption, largely based on these findings. And we also started to cut back on dairy consumption, especially when alternatives became available like the soy and rice non-dairy beverages. Basically, I just ate what was put in front of me, what my parents told me was good food. I certainly did not know about some of these amazing findings from the China Project that my father had uncovered. But Colin's contributions to diet and cancer research and his activities in policy development did not go unnoticed in the larger population. His work garnered him several awards, including the 1998 award from the American Institute of Cancer Research for a lifetime of significant accomplishments in scientific research. He was named by Self magazine as one of 25 people that changed the way we eat, cook, and think about food, and he has received other awards as well as significant media attention. But having seen a glimpse of some of Dr. Campbell's research findings, what should you, the viewer, make of it? Imagining myself in the shoes of someone who hasn't heard this information before, I have to admit, I would still be skeptical of the benefits supposedly attributed to a plant-based diet. What you have seen in this video, a selected few research findings from one scientist and his colleagues and students, is far from constituting proof of the absolute superiority of a strict plant-based diet. Some of the criticisms of the China Project, stated in the proper context, have merit, and the laboratory studies on casein and cancer, although they were of the highest quality, were far removed from proving that milk protein causes human cancer. There is no such thing as a flawless research study in the realm of food and health that absolutely proves any hypothesis, and health information coming from one source, no matter how good it may seem, should be regarded with some degree of wariness. But while I encourage you to remain skeptical, and I almost hope that you do, I would also ask that you at least allow yourself to consider the possibility that all of this information might be true, that a whole foods, plant-based diet full of unrefined fruits, vegetables, and grains, and devoid of meat or milk, is the healthiest diet, that this diet can prevent and even reverse a variety of diseases and conditions and lead to increased vitality and functionality in everyday life. The research described in this video, while it does not offer absolute proof, is remarkable for its quality, its comprehensive design, and especially its consistency of findings. If you were to continue searching for scientific information regarding this diet from other researchers and clinicians, and it wouldn't be hard to find, you would be able to find published evidence that heart disease and diabetes have been reversed with this same diet, that weight problems can be resolved with this diet, that the incidence of breast cancer, prostate cancer, colon cancer, and other cancers is lower in those areas that consume more of a plant-based diet, that autoimmune diseases, eye disease, bone disease, brain disease, and many other types of ailments and conditions have been shown either to be prevented by this diet or made worse by America's current diet laden with animal-based foods and highly processed plant-based foods drenched in added sugars, fats, and salt. Foods such as French fries, potato chips, and sodas. When all of this evidence is brought together, something that I did in the process of co-authoring the China study, the idea of sustained skepticism seems a bit silly. It's almost as silly as saying that smoking is unrelated to your health. It really does become clear that if nutrition were properly understood and utilized, we as individuals and as a society would reap innumerable benefits. Chronic disease rates would drop, and with them, so would the crippling cost of health care. And our old age may be more rectangularized, a term that describes having full functionality until our very last days. In other words, we may be more functional, more independent, and pay less health care expenses in our later years. The health care storm that threatens our society would diminish, leaving us with more hope, more wealth, and more health to enjoy it all.